This video is on factoring, and I'm going to cover 4 types of factoring. GCF, super easy, done it for a long time. Difference of two squares, you've done since Math 1. Cubes, you've learned more recently. And trinomials, you've kind of learned a little bit in Math 1 and then finished in Math 2. Again, because this is a review, I'm going to go kind of fast. This is the most important foundational block, the cornerstone of your math tools that you need to have readily available and to be able to do like super quick without a lot of thought, second nature. So this is a skill that needs to be really, really sharp. So feel free to watch and slow down and rewind and go back and do whatever you need to do so that this skill is not something that you stumble over. These are skills that you're going to use to solve problems. These problems aren't the end result. Factoring is a tool to get to the end result. Okay, so GCF stands for greatest common factor. So I'm going to take out the biggest thing possible. Take out a 3, write what's left over. Take out a 4 and an X. There we go. Let's see, 6 and x squared. First term would be 3x squared minus 7 with no x's plus an x. And then this one, 4a squared and a b. First term is 5 and an a. 3 and a b, and nothing, so then I put a 1 there. That way when I distribute this back, I still get that term. Okay, so trinomials. So the first 8 trinomials that are here, you can tell that there's no leading coefficient with the x squared. And then when we get on these later ones, you can see that there are coefficients. When I teach this in Math 1, I teach these 2 types very differently. If you follow the sign rules, then you'll never miss these. So these are little easy trinomials. I'm looking for the factors of 15 that add to give you 8. So for this one, I'm looking at the factors of 24 that subtract to give you 5. Sometimes people focus on whether it should be a positive or a negative number too quickly. Some people even put their signs in before they ever put their numbers in. I'm not a fan of that. But, you know, to each their own. So the factors of 15 that add to give me 8 are 5 and 3. I want a positive 8. So they both need to be positive. 24. Okay, now, so this is a great example. I need the factors of 24 that add to give me 10. So that's 4 and 6. But let's say this problem was this. So the only difference is I've changed the last sign. I now want the factors of 24 that subtract to give me 10, which would be 2 and 12. So just because I changed that one little sign, the numbers for the solution changed completely. So that second sign is really crucial. So for this, I want to add to give me 10, so 4 and a 6, and I need a negative 10, so they both need to be negative. And then the negative 4 times the negative 6 is what gives me the positive 24. And then if I go back and do this one up here, I need the factors of 24 that subtract to give me 10. That's 2 and 12. And I want to end up with a negative 10, so I want a negative 12 and a positive 2. And then that's how I also get the negative 24 is that my signs are different. Number 3, I want the factors of 10 that add to give me 7, 5, and 2. Negative 7, so negative 5, negative 2. 36 that adds to 13, 4 and 9. 24 that subtracts to give me 5. That's 3 and 8. I want a negative 5, so negative 8 and positive 3. 8 that subtracts to give me 2, 4 and 2. I want a positive 2, so positive 4, negative 2. It's funny people struggle with ones like this where you're trying to subtract to get a 1. if you're subtracting to get a 1, then your numbers need to be side by side. A lot of times for this one, people put 42 and 1, but it's 6 and 7. Because again, I need them to subtract to give me 1. Now I want a positive 1. So positive 7, negative 6. Sorry about that. Let's fix that. 18 subtracts to give me 7. That's 2 and 9, negative, positive. Okay, so those are super easy. They don't have a leading coefficient with their x squared. That makes them wonderful. For the rest of these, it takes a little bit more thought, and you have to watch out for the sneaky GCF, like in number 9. I can take a 2 out and then do my trinomial. And don't lose that 2 in the front. That's part of your answer. Number 10 does not have a GCF. So I'm going 3x and x. Those are my only 2 options. I need to go 2 and 1, but I need to do the 2 and the 1 in a way so that when I put them in there, I'm going to subtract to get a 5. Now, that's really important because I could put a 2 and a 1 in here so that it adds to give me 5. So I'm going to show you the wrong way first. So if I look at this, that's going to be a 2x, and that's going to be a 3x, and that adds to give me 5x. And a lot of people say, well, I just need to get a 5x. But to me, it's really important to focus on how. I want to subtract to get a 5x. So this won't work because if I need a negative 5, then both of these need to be negative, and that's not going to give me a negative 2 in the back. That's going to give me a positive 2. So I need to go 2 and 1 here. That gives me 1x, and that gives me 6x. And that can subtract to give me a negative 5x. The sign down here on the bottom is going to go in the back because that's what makes the 6. And this plus sign is going to go right there. Now, the goal is to be able to do this, this part right here kind of in your head or in the air or, you know, with your pencil or in your brain so that you don't have to write that out every time. And the more you do of these, the better you'll get. So 5x and x are my only options. And just like a hint for numbers that can go like 2 different ways, like this can go 1 and 4 and 2 and 2. My high school math teacher, one of the only things they taught me that was really good was when you do trinomials, about 80 to 85% of the time, it's going to be the 2 numbers that are closer together, like 2 and 2. 4 and 1 are farther apart. Now, that's not saying that that's always the case, but if you have to pick a pair to start to try with, always start with the 2 that are closer together. And here that's going to work because that gives me a 2x and a 10x, and that'll subtract to give me an 8. I want a positive 8, so I want a positive 10 and negative 2. That's going to make the positive 10, and that's going to make the negative 2. And again, I'm writing this out because normally if I was doing this in front of the class, I would kind of be doing it up on the board. So I'm just kind of pointing out what I'm doing, but I'd love for you to not have to write that out. Okay, and again, I could go 1 and 6, or I could go 2 and 3. I'm going to start with the 2 that are closest together, so I'm going to start with 2 and 3. I've got a 3. My only options are 3 and 1. I'm trying to subtract to get a 7. So if I go 3 and 1, that's a 9x and a 2x, and that's going to work. I want a positive 7. So there we go. And again, I'm going fast. Feel free to pause, digest it a little bit more. And I'm also on these, I'm keeping an eye out for a GCF, a sneaky GCF. 5 and 2, I'm trying to add to get a 21. 5 and 2, that'll work. Because that's a 6 and that's a 15. And everybody's positive. 8, I could go 8 and 1, but I'm going to try 2 and 4. I'm trying to add to get a 10. Ooh, see, and I could subtract to get a 10. I could subtract to get a 10 and do this. So I just want to show y'all why this is wrong. These are just a lot of common mistakes. And they'll say, okay, I want a negative 10. So I want a negative 12 and a positive 2. So I'll put a plus here and a minus here. And that's great. That gives me the 8x squared, and that gives me the negative 10x, but it does not give me a positive 3 in the back. That's going to give me a negative 3. So that is not going to work. So let's try 2x and 4x, and let's go, yep, 3 and 1. There's your 4x, there's your 6x. I want a negative 10. There you go. That gives me my negative 10, and it still gives me my positive 3 in the back. Number 15, be careful. There is a GCF. Don't let it sneak up on you. And then this is no coefficient in the front, so it's a super easy trinomial. This one has a GCF. Oop, I forgot my 6. 3x and 2x. 2 and 1, because that's a 4x and a 3x. Positive, negative. Okay, and 17 looks really intimidating, but it's not. It's got the y squared in the back and the xy in the middle. Just like we have an x squared in the front, and so we'll go 5x and 4x. When it has the 3y squared in the back, we'll go 3y and 1y. In fact, I'm going to go ahead and put that in there. I'm trying to subtract to get an 11. And again, with 20, I have 1 and 20, 2 and 10, and 4 and 5. I'm going to stick with the 2 that are closest together and see how that works. I'm trying to subtract to get an 11. 5, there it is, 15. So 5x and 4x, because that gives me 15xy, and that gives me 4xy, and I want a negative 11. So positive there and negative there. 18 is the exact same, so I'm going to skip that. Okay, so for squares, all numbers must be squares. These we should know by now. 8, 9, 10, 11, 12, 13. You need to know, that's a terrible 8. You need to know up to 13 squared. And don't forget 1. 1's a square. All your powers must be even. That's because x squared is a square because it's x times x. X to the 10th is a square because it's x to the 5th times x to the 5th. So powers don't have to be squares. They just have to be even. To be able to do squares, the sign in the middle has to be a negative. Has to be. And I'll show you why it doesn't work for a positive. So number 1 fits all the conditions. 81's a square. My power's even. I have a subtraction sign and to factor squares. It's super easy. It's the same thing in both parentheses. 81 is a square because it's 9 times 9. 1 plus, 1 minus. Here's why. If I were to multiply this back out, I need these middle 2 terms to cancel out. And that's why I have to have 1 plus 1 minus. Now, in having 1 plus 1 minus, that's why that 81 has to be negative, which is why the sign in the middle must be negative. So let's work on number 2. So that's going to be x plus 5x minus 5. Number 3 is prime. Cannot be factored because, yes, the 4 is a square and your power is even, but there's a plus sign in between. Number 4, do not flip this around. You do not have the power to do that. Leave it alone unless you want to pull this negative 1 out of your back pocket, and that just makes it messier. So for right now, just leave that alone. Number 5, 4 and 49 are both squares. So I'm going 2a and 2a, 7 and 7, 1 plus 1 minus. 9 and 64 are both squares. All my powers are even. This is just a big one. 3xy squared. Notice I'm cutting all my powers in half. 8z cubed. 1 plus, 1 minus. X squared plus 10, x squared minus 10. It's funny, on this one I get a lot of 50s, but 50 times 50 is not 100. I also say, ooh, I can go again. That's x squared and that's a negative. Yes, but that 10 is not a square, so you cannot keep going. This is x cubed plus 1, x cubed minus 1, which are cubes, but we're not focused on that right now, so I don't want to dive into that. But that's it for squares. And again, don't flip this around. 4m squared, 3 minus 4m squared, a squared plus 9, a squared minus 9. Okay, now let's look at this one. This one can go again. This piece right here is done because you've hit a plus sign, but on this one over here, your power is even, your number's a square, and that's still a subtraction sign. So that one's done, but this one can go again. Cut my power in half. And again, this one can go again on the minus because 4 is still a square. Now, 1 can go forever. So you're going to go until your powers run out. I have a feeling I'm going to run out of room. So x to the 8th plus 1, x to the 8th minus 1. Okay, he's done. This one can go to the 4th. Then this is done and this is done. This one can go again. And now he's done and he's done and he's done. And this one can go again. Oh, not squared, sorry. And now you're done. So it's that guy, that guy, that guy, that guy, and that guy. There's your answer. That was a doozy. So then when I look at number 13, these are not squares. So just because it's on the screen with squares does not mean that it's squares. 27 is not a square. 12 is not a square. X to the 5th is not even. So I need to be able to kind of bounce back and forth between all the different types of factoring. This is a GCF. I can take a 3 out and an x out and a y squared out. And that's going to leave me with 9x to the 4th minus 4y squared. And now I have squares. Oh, sorry. 3xy squared, 3x squared plus 2y, and 3x squared minus 2y. 14, be careful because it looks like squares, but first it's a GCF. You can take a 25 out and then do squares. 15 is the same thing. 16 and 4 are both squares, but first take the GCF out and then do squares. So you can see when I list all the types of factoring, the first thing you always try is GCF. And then depending on how many terms you have, that's when you try something else. But number 1 is always GCF. If you have 3 terms, you do a trinomial. If you have 2 terms, you're either going to do squares or cubes. 4 terms is grouping. That doesn't pop up that much, so we're not really going to cover that. So we've done GCF and trinomial and squares, so our last one to do is cubes. Cubes are a little bit more involved than squares. All your numbers have to be cubes. So those numbers are 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, which is tricky because that's also a square. 5 cubed is 125, and 6 cubed is 216. That's as high as your brain needs to go. Obviously, that's not as high as the list goes, but that's how high you need to be able to recognize. All your powers must be divisible by 3. When we did squares, all the powers had to be even or divisible by 2. So these must be all divisible by 3. And the sign for cubes can be positive or negative, and this is where you're going to use SOAP. Same, opposite, always positive. Okay, so 125 is a cube. My power is divisible by 3. I don't care about my sign. I'm going to have a short and a long. What goes in the short is what makes both of these a cube, and that's x and 5. Notice I'm not putting any signs in here at all. Then this spot that goes right here is always this guy squared. This spot way back here is always this guy squared. Then this spot right here are these two multiplied together. Every single time, follow that pattern. And then my signs, I have 3 places for signs. I have one right there, one right there, and one right there. So I'm gonna, same as the original problem, opposite the original problem, and always positive. So same as the original problem, opposite the original problem, and always positive. Number 2, short and long, a and 27 is 3 cubed. Then this guy is a squared, and this guy is 9, and then multiply them together. So honestly, once I get these 2 guys down, I don't look at this anymore. To get these 3, I'm looking here. And then same, opposite, always positive. 8's a cube, 1's a cube, power is divisible by 3. So 2x and a 1, square it, all of it, square it, multiply them together, same, opposite, always positive. 27 and 8 are both cubes. 3a and a 2, square all of it, square it, multiply together, same, opposite, always positive. 216 is a square. 6, square it, multiply it together. Same as the original, opposite the original, always positive. 64 and 27 are both cubes. 4x and a 3. Square it, multiply together, same, opposite, always positive. Divisible by 3, and 1 is a cube. I know this isn't squares because there's a plus sign, and I can't do squares with a plus sign. So I'm going to divide that by 3, so that'd be x squared and 1. And then I square it, and a power to a power, I multiply. Square it and multiply. Same, opposite, always positive. 7 and 56 are not squares, but I can GCF and then do cubes. Or 7 and 56 are not cubes, sorry. I think I said squares. 2, square it, multiply, same, opposite, always positive. There you go. All right, so that was GCF, trinomials, both the hard and the easy ones, squares and cubes. Like I said, this should have been a complete review, but I know some of you may be dustier than others, so spend as much time as you need to on this because you need these skills to be super sharp